The aim of this video is to introduce the basic concepts of ACTUS, the problems ACTUS solves, and how these are solved. ACTUS is a worldwide open source initiative with 3 elements, and these are as follows: the data dictionary, the code definition, and the Java reference code, which can all be downloaded from GitHub. ACTUS stands for Algorithmic Contract Type Unified Standard. The most important letter in this acronym is the letter A, which stands for Algorithmic. In other words, ACTUS represents the legal intention of 2 counterparties in a financial contract to exchange payments with well-defined and standardizable algorithms. In order to understand these algorithms, it is best to start with the problems we are facing in the financial sector today, which requires a solution. This physical model is a great example that describes the dire state of the current finance industry. We will use this model to demonstrate the general state of the industry and how we can solve this situation. Rabobank produced this model in order to understand their own complex architecture. We downloaded this from a website. The lower part of the model shows the transaction processing or core banking systems in which the financial contracts are processed. Each box represents a system. You can see there are so many of these boxes because this bank has grown through mergers of local mortgage banks, and each of these banks brought in its own system or box in this representation. As they merged, they wished to get rid of these boxes. However, very often this did not materialize. In many cases, they ended up with more boxes due to failed integrations. The upper level of the model shows the management level, including the customer interface at the front. The management level can be conceived as 3 main departments. On the left we have, for example, the finance group. In the middle, risk management, and to the right, the regulatory department. Each of these departments have plenty of sub-departments and each with their own systems. From below, the system looks like this, and this is even a simplified picture. There are so many lines because each system below must communicate with potentially most of the other above systems. Because of the missing common language to represent financial contracts, each line is an expensive data mart which translates the language of the lower systems into the language of the upper systems. All these systems are obviously not sustainable and makes progress very expensive, if not impossible. It paralyzes development because a change in one corner of the system has surprises and unintended consequences in other areas. Why do they have this complex architecture? The reason is a missing common financial language. This common financial language is ACTUS. The root problem, as we saw, lies in the missing common language. This language can be best understood if we think first about the financial contracts themselves and how they are conceived today, and how ACTUS represents them for the technology of tomorrow. Today, financial contracts are wordy, written by lawyers, and avoid any mathematical expression. However, at some point, the essence of the contract comes into play. The key point, which is the central intention of the parties to the contract, is an exchange of payments between counterparties according to a set of rules. Here we see a pattern of a typical bond and a rather complex mortgage. Note the abbreviation PAM below bond stands for the general pattern principal at maturity, and AN below mortgage stands for the general pattern annuity. We will discuss the mortgage or AN example in the following slides. How do we solve this problem? As I mentioned already, ACTUS stands for Algorithmic Contract Type Unified Standard, and the most important letter in this acronym is the letter A, which stands for algorithmic. So what do we mean by algorithmic? The algorithmic nature of financial contracts derives from the following unique features. Financial contracts define an exchange of payments which follow well-described algorithms or mathematical rules. A bit more concrete, financial contracts are pure exchanges of payments or cash flows. I give you money and you give me money back, following a certain pattern or sequence. Cash flows are units of account which can be represented by pure numbers. The rules which define the sequence of payments can be represented by well-defined algorithms. Most interestingly, the number of patterns which cover almost everything is not overwhelmingly large. ACTUS has defined and standardized these patterns as algorithms and makes them available in a reference Java code. In other words, with ACTUS, it is possible to define financial contracts as true digital assets or smart contracts, since numbers and algorithms can truly reside in computers. It is interesting to note that these are very specific features of financial contracts, which puts the financial sector into a unique position. This uniqueness should have enabled the financial industry to be in the forefront of automation when compared to other industries. However, the reality is different, as we have seen from the physical model. What we can see are the patterns of exchanges found in the world of finance, ranging from simple savings to mortgages to swaps, options, CDOs, and so on. If you go to the ACTUS website, which is actusfrf.org, you will find the explanations for each acronym. Two of the acronyms were in the previous slides. They are on the left side below the box Maturity. PAM stands for Principal at Maturity, a pattern most bonds follow, but also many loans. Below PAM, we find ANN, which stands for Annuity, a pattern followed by most mortgages, except in Switzerland, but also leasing contracts, life insurances, and so on. Behind each acronym is a set of well-defined functions or algorithms which define the intention of the two counterparties to a financial contract. A vital feature is the small number of patterns. What we see here covers almost all contracts out there except hyper-exotic instruments. A normal bank runs on 5 to 7 patterns. With ACTUS, all patterns needed in the future are available by avoiding the continuous complex integration of new systems which occurs in the traditional architecture. ACTUS has therefore brought a unique contribution to the world of finance, and it is open source. On the left side of this slide, we have the typical banking or on-balance sheet products. Let us focus on the ANN patterns, which we think is sufficient to understand the system. ANN stands for annuity, which is the pattern where the payment of interest and principal is a constant. Due to the reduction in balances over time, however, the principal part increases and the interest part decreases. Let's focus on a mortgage. In order to model the mortgage, we need some important parameters related to the exchange of cash flows, typically found in contracts such as initial exchange date, maturity date, notional interest, and a few more, as we see at the bottom left. Note the bidirectional arrow between the contract and the ANN contract type. In today's IT environment, the arrow would point from left to right. In the legacy world, the real contract is the paper legal contract, which is then taken by a programmer and turned into code, which corresponds more or less with the reality of the paper. With ACTUS, on the other hand, we have two possibilities. First, we can map any existing contract from any legacy system into the ACTUS format and get a standardized representation. However, it is even possible to turn it around. Since the legal intention of the counterparties is well defined and coded within the contract type ANN, it is possible that the legal contract refers to ACTUS when it comes to the exchange of cash flow. This is the only way to guarantee the consistency between legal intention of the counterparties and the real implementation within the IT landscape. This code, or the algorithms related to ANN, can be executed, and it generates this payment or cash flow exchange pattern, which is also shown here in tabular form to the right. This table represents rock bottom of finance, from where any other number of interest, any type of value, cash flow, income, profitability, any sensitivity or risk number is derived. These are the numbers which are always needed for transacting, trading, securitization, and analyzing the financial contracts, from simple accounting to rocket science analytics. This table is the secret behind the consistency of the ACTUS approach. To transact, to manage the life cycle, to tokenize and securitize financial contracts is one thing. The other important thing is to understand the financial consequences of the transaction. Based on ACTUS, it is now possible to build top quality transaction processing systems and analytical engines for the risk and finance space, since transacting and understanding the financial consequences are simply two sides of the same coin. What we see here is such an example. It is possible to see the consequence very near time in your balance sheet, actually in your balance sheets if you have multiple accounting concepts, as we see them here on the slide. We see side by side 4 balance sheets in nominal, fair value, IFRS and local GAAP terms. And they are all 100% consistent because the underlying expected cash flow is always based on the same ACTUS algorithms. Balance sheets and accounting is only the beginning. You will have any financial analytics such as the liquidity forecast for the treasurer, a stress testing result for the market risk manager, or the credit exposure for the credit risk manager, just to mention a few, on your fingertips. ACTUS is the base for the best strategic planning and budgeting tool. You can define your strategic plans very intuitively based on contract types, and you will always get meaningful output such as P&L, future balance sheets, as in this example, the evolution of equity, and expected liquidity. The features of these analytics allow a level of consistency which has never been achieved so far. We have consistency between finance, risk, and regulation, different financial products, transaction processing and analytics, any analytic methods, which really solves the current reconciliation problem which all banks experience that have grown through mergers. It makes consistent real-time financial and risk analytics and continuous audit a reality. If you have more questions, please visit our website or contact us at contact@actusfrf.org. Thank you.